Hello friends, welcome to the session on 8051 microcontroller unit. In this session, we'll be discussing about addressing modes for the microcontroller 8051. In this session, we will see what is we mean by addressing mode for 8051. What are the different types of addressing mode available for the microcontroller 8051, and we will see the suitable examples of these addressing modes. Friends, as you know that you are viewing this session on my YouTube channel, and do subscribe to the channel to see many videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by addressing modes for the microcontroller 8051. Microcontroller 8051 can be used in variety of applications. So for example, whenever we want to make the use in embedded system, then it is possible to design the embedded system by making the use of 8051. In 8051, the programmer needs to write assembly language program. And whenever the programmer needs to write the assembly language program, then it is necessary to make an access to the data during the execution of the instruction. And there are different methods for making an access to the data in the execution of the instruction. And these different methods which are used for making an access of the data are being called as the addressing modes for 8051. 8051 addressing modes can be classified into different categories. So we can have the different categories, and we can say that about there are 10 different addressing modes for the microcontroller 8051. And these addressing modes are immediate addressing mode, register addressing mode, direct addressing, indirect addressing, index addressing, relative addressing, absolute addressing, long addressing, bit inherent addressing, and bit direct addressing. So as far as the addressing modes are concerned, one can easily find that there are large number of addressing modes available for the microcontroller 8051. So let us understand each one of them. The first one is being called as an immediate addressing. In the immediate addressing, the data is being provided as the part of the instruction itself, and therefore the data will be available immediately after the opcode of the instruction, and such addressing is being called as the immediate addressing. Say for example, when we write the instruction such as move a comma hash 99h, then one can easily find that the value 99h will be moved to the accumulator A. So this hash will tell the assembler that this addressing is an immediate addressing, and the data will immediately appear after the hash symbol. So such type of the instruction where we make the use of the hash followed by data is being called as an immediate addressing. Another addressing that is very popularly used is the register addressing. In the register addressing, we can make the use of the registers to hold the data, and this data can be manipulated. We know that in the internal RAM structure of 8051, we have seen that the lowest 32 bytes of the internal RAM are being organized into 4 banks of 8 registers. That is, we can have the registers from R0 to R7, and these registers can be used to hold the data, and this data can be manipulated by using different instructions, and such addressing is being called as the register addressing. Say for example, when we write the instruction such as move a comma R5, then the content of the register R5 are being copied into the accumulator A. So this is the addressing which can be called as a register addressing. Another addressing that is being called as a direct addressing. So in this mode, you will find that the access to the internal data memory is being provided. Also, the access to the special function register or SFR is also provided. So in this addressing mode, the 8-bit internal data memory is being specified as the part of the instruction, and Hence, it can specify the address only in the range of 00 to FF. So one can make the use of the instructions such as, for example, if we write the instruction move a comma 47h, then one can easily observe that the address of the memory is a part of the instruction itself, 47, say for example in this case. So whatever is the content of the memory 47h, which is the part of the internal RAM, is being moved to the accumulator. So such type of the addressing is being called as a direct addressing. So direct addressing indicates that the location address, memory location address, will directly appear in the instruction itself. Another addressing mode that is being used in 8051 is the indirect addressing. The indirect addressing mode will use a register to hold the actual address. So in direct addressing, we are actually giving the address of the memory, but in indirect addressing, we will make the use of some register to hold the address, and that will be used for the movement of the data. Say for example, we can make the use of registers such as R0, R1, and data pointer register DPTR that can hold the address. Say for example, when we write the instructions such as move a comma at RO, so whenever this symbol appears at, so you can easily understand it makes the use of the indirect addressing. So whatever is the content of RO, say for example, if the content of RO is 54, then we will look into the RAM of 54 address, and the content of that memory will be moved into the accumulator. So here one can easily observe that the address of the location is being held by the register such as RO, R1, or DPTR. So such addressing is being called as an indirect addressing. Another addressing that is very commonly used in the instruction set of 8051 is the index addressing. In the index addressing, a separate register such as program counter or data pointer is being used to hold the base address, and then the accumulator is used to hold the offset address, and the base address and the offset is being added together to compute the effective address, and such addressing is being called as the index addressing. So index addressing is normally used with jump instruction or movec instructions. Say for example, when we write the instructions such as movec a comma at the rate a plus dptr, then the content of dptr will be added into the content of a to compute the new address, and then the content that are located at this address will be moved to the accumulator. Another addressing that is being called as the relative addressing, and this addressing is being used only with the conditional jump instructions. So in the relative addressing, the relative address is being computed. The relative address, which is normally referred as an offset, and this offset is an 8-bit sign number. So it can be positive or negative sign number, depending upon whether you want to jump in the forward direction or whether you want to jump in the backward direction. In case of forward jump, this address is positive. In case of backward jump, this offset is negative. So this is automatically added to the PC. That is the content of the program counter to make the address of the next instruction. The 8-bit sign offset value can be in the range of +127 to -128. So jump destination is usually specified by using a label, and the assembler will calculate the jump offset accordingly. So whenever we make the use of the conditional jump statements in the assembly language program for 8051, then you will find that normally we will make the use of a label such as X or loop, and then we will jump to the particular instruction that is located at that label. So assembler will automatically calculate the relative address, and then the jump will take place. Say for example, suppose our PC is set to the next instruction 2002. So this is the location where the PC is being set. And suppose currently we are executing the instructions such as sign jump, which is labeled as X. And suppose the X label is at the address 2006. So one can easily find that the difference between the content of PC and the label X address is just nothing but of 4, and therefore this offset is 4, and therefore this offset 4 is being added into the content of the PC 2002, and then the effective address in the PC will be computed, and that will be 2006. So such type of the addressing is being called as the relative addressing. Another addressing that is being very commonly used in case of instructions for 8051, that is being called as a absolute addressing. This absolute addressing is being used with the absolute jump or absolute call instructions. So these instructions are the 2-byte instructions. So the difference between the relative addressing and absolute addressing is that in case of absolute addressing, only the lowest 11 bits of the memory address are the part of the instruction, while the upper 5 bit of the destination address are the upper 5 bit of the current program counter. And therefore, one can easily calculate that the absolute addressing will allow the branching only within the range of current 2 kilobyte page of the program memory. So for example, we can write the instructions such as AJMP or absolute jump loop. So one can easily observe from this figure that in the absolute addressing, the most significant 5 bits are fixed and that are the same to that of the content of the program counter. Only these bits are being specified into the instruction, and therefore these bits are changed, and therefore the jump can take place only within the nearby 2K page only. Another addressing that is being used is the long addressing. Long addressing mode within the 8051 is being used with the instructions such as long jump, LJMP, or long call, LCall. So these instructions are the 3-byte instructions. So address specified is being specified in the form of 16-bit destination address, so that a jump or call can be made to the location within the 64 kilobyte code memory space. Say for example, when we write the instructions such as long jump 500H, then one can easily observe that the destination address is being mentioned in the instruction itself, and therefore the jump will take place from the current instruction to the instruction that is being stored at this location. Another addressing mode is the bit inherent addressing. In this addressing, the address of the flag which contains the operand is implied in the opcode of the instruction. Say for example, when we write the instructions such as clear carry flag, then CLRC, so one can easily observe that the carry flag will be affected. So this is the carry flag bit will be affected, and therefore such type of the addressing is being called as the bit inherent addressing. There is another addressing mode that is being used, and this is the bit direct addressing. So in the bit direct addressing, the RAM space 20H to 2FH and most of the special function register SFR are the bit addressable. So bit address values are in the range of 00 to 7F. Say for example, when we write the instructions such as clear 07, then the 7th bit will be cleared. Or when we write the instructions such as set B07, then the 7th bit will be set. So whenever we want to set a particular bit, or whenever we want to clear a particular bit of the RAM space, then it is possible that you can make the use of such addressing that is being called as the bit direct addressing. Thank you, friends, for viewing the session. Hopefully, you have understood what we mean by addressing modes of 8051. In our next session, we will start discussing the different types of instructions that are available for the microcontroller 8051. Thank you all for viewing the session.